Number one. Okay, super important. The factoring is not going to go away anytime soon. So if you're having trouble, come see me. We can practice. But definitely do not no chat GPT, no Google, no photo math. It's super important that you learn how to do these factoring problems on your own. So this one has a coefficient in front of the squared term, which means it is difficult. So we're going to have to do the rainbow. So 4 times negative 24 is negative 96. Okay, so rainbow. Now we're going to do the diamond. So I need two numbers that multiply to get negative 96 and add to get negative 29. Since it is less than 100, you can find it on the chart of factors. So let's write down all of the factors of 96. Okay, now we have the factors of 96. We need two numbers whose product is negative 96 and whose sum is negative 29. So let's see, will this work? If I do negative 32 and positive 3, when I multiply, I will get negative 96, and when I add, I will get negative 29. So here are our numbers, and we are done with those. Okay, rainbow, diamond. The next step is make a box. 4v squared goes here, negative 24 goes here. I need to split the negative 29v into two numbers whose sum is negative 29. And I found them right here, negative 32v, right? Because that's what we're doing. And 3v. Okay, so let's find the GCF of the top row. So what comes out is 4v. So 4v times v is 4v squared. 4v times negative 8 is negative 8v. 3 times v is 3v, and 3 times negative 8 is negative 24. So I have 4v plus 3 and v minus 8. Okay, someone in one of their videos described these as the wings. We find our answer on the wings. I like that. Number 2. Okay, this is looking like the sum of cubes, but 24 is not a perfect cube. 375 is not a perfect cube. Let's try dividing by 3. Let's see if there's a GCF. So 24 divided by 3 is 8, and 8 is a perfect cube. 375 divided by 3 is 125, which is also a perfect cube. Okay, we could see from the table of cubes that 8 is 2 cubed and 125 is 5 cubed. From those cube roots come our first part of the expression. So 2x plus 5. Okay, so now I don't know how your brain works. For my brain, I like to just kind of memorize it. You could also now do a division problem to get the part that is remaining. We could use the rules and we could kind of use a little song. Okay, so let's talk about the rules for the sum of the cubes. Okay, so the cube roots go here And then we square the first, square the last, multiply these two together, and change the sign. So that's going to be negative AB. So that's how I do it. There's other ways to do it. We can talk about it. If this method does not work for you, there are other methods you could look at. So bring down the cube roots, square the first and square the last, multiply and change the sign. There's also another video where I saw this gal. She has another little song. However, you can get this so that you understand it. You're going to have the formula in your notes when it comes up, but you just need to be able to apply it. So what I'm going to do is square the first and square the last, multiply them together, and change the sign. Yeah, square the first and square the last, multiply them together and change the sign. So this is 2x plus 5. We're not done. This is, oh, there's a typo. I squared it and I wrote it down. Okay, sorry. Yeah, are we fixed? Okay, square the first and square the last. So this is 4x squared minus 10x plus 25. Number 3. This little symbol right here says to multiply them together. So one thing I've noticed, some of you are not putting parentheses when you multiply them together. Put parentheses around them. So now we're going 2 terms by 2 terms, and you know what that means. That means we need to make a box. So 2t minus 5, t cubed plus 2t. So multiply to fill in your box. Okay, so we filled in our box, and now we're looking at the inside of the box, the inside contents. Now, don't forget to put them in descending order of exponent. 2t to the 4th minus 5t cubed plus 4t squared minus 10t, and we are done. So find all zeros. So we want to know what x value would make this expression equal to 0. Now, we can see that one of them is actually x equals 0. If I plug 0 in here, boom, it's going to just wipe everything else out. So I can see that x equals 0 is one of them. But there's more. Okay? So step 1 is to factor. And what if it's not factorable? You're going to have to do quadratic formula. But this one's already factored for us, so we're okay. Split and solve. So a lot of you are getting really good. That means x equals 0. That means x equals positive 2. But what do I do if there's a coefficient in front of the x? So how can I make this equal to 0? Let's subtract 3. 5x is equal to negative 3. Divide by 5. X is equal to negative 3/5. So this one was already factored. We could just split and solve and get 0, negative 3/5, and positive 2. Now, you are done. You don't have to do anything else. But can you see, is any of these a double root? Yeah. Okay. Just, it's good to recognize, oh yeah, that's a double root. That's not what this question's asking for. But I remember learning about double roots. Okay. Number 5, solve with the quadratic formula. Now, the more you practice the quadratic formula actually practice it, not just watching me do it, but do it on your own. Okay, so try this on your own, pause the video, and then you could watch me do it. So, solve with the quadratic formula. The first step is everything has to be on one side and you need to set it equal to 0. So, let's add 8 to both sides so that we have 0 on the other side. So now we can plug into the quadratic formula. So technically, that's not x, that is b. We have one variable in here. So b is equal to negative b, opposite of b, plus or minus the square root of b squared. That right there, since you're squaring it, will always be positive. Minus 4 times a times c all over 2 times a. You can see my brain sometimes jumps ahead of me. Okay. So that looks intimidating, and I don't know where to go next. Okay. So just breathe and let's just simplify the square root. Okay. So we're going to enter that into the calculator with parentheses, negative 4 squared minus 4 times 6 times 8 equals negative 176 all over 12. Okay, now beep, beep, beep. We see that there is a negative inside the square root. So that tells us we're going to have an I in there. Okay, so I'm just going to go ahead. So this is negative 1. Square root of negative 1 is I. I just want to get rid of that so that I don't forget it later. Okay, 176. So we want to know the factors of 176, or you could just divide it by the perfect squares. Divide it by 4, by 9, by 16, by 25. Okay, or we could split it into its factors. 176 divided by 2 is 88. I can see that there's no 3 in it. Divided by 4 is 44. Let's see, no 6 because there's no 3. Divided by 8, 176 divided by 8 is 22. I could see that there's an 11. 11 times 16. Okay, I think I found, there might be more factors, but I think I found my perfect square right there. So this is biggest perfect square and leftovers, which is 4 rad 11. Okay, so here we are. Now we are going to look at the outside numbers. Can I divide them all by the same thing? Do they all have a greatest common factor? Yes. So I'm going to divide them all by 4. So I have B is equal to 1 plus I rad 11 over 3 and 1 minus I rad 11 over 3. Or you could say 1 plus or minus I rad 11 all over 3. Okay. Number 6. This is the new material. So we're going to analyze this polynomial. We want to know the number of zeros total. Okay, real or complex. the possible number of real zeros, possible number of imaginary zeros, and all possible rational zeros. Now, rationals, those are not square roots, right? Square roots would count as reals because those are decimals. So possible rational zeros. And then we're going to solve for the zeros. So here we go. Degree 4. That means I'm expecting 4 zeros. Now, if all 4 are imaginary, then that leaves none left to be real. The imaginary zeros have to come in pairs. Otherwise, do you see an I in our polynomial? No. That means the imaginary zeros have to come in pairs. So there could have been 4, there could be 2, or there could be 0. There's 4 total. If there's 2 imaginary, 2 real. 0 imaginary, 4 real. Okay, number of imaginary zeros, 4, 2, or 0. Number of real zeros, 4, 2, or 0. Next, possible rational zeros. Okay, that is the P's over Q's. So for the P's over Q's, we need the factors of the end number, the constant term, the one without a variable, that's going to go on top. And on the bottom are the factors of the leading coefficient. Well, that's just plus or minus 1. So the bad news is, look at all these factors of 64. So they're all going to be divided by 1. There's not going to be any fractions. They're going to be divided by 1. So the possible rational zeros, plus or minus 1, plus or minus 2, plus or minus 4. Okay, so there are the possible rational zeros, and then those are all divided by 1. So we don't know. They could all be imaginary, and none of these could be a 0. But these are the possible rational zeros. There's no 7. It could only be one of these. Okay, so let's set this equal to 0. Now, what we could do is we could plug in all of these numbers, and we know that if we plug it in and get 0, it is a 0, which would not be too bad, right? So let's try -4. -4 to the third power is 256. So no, -4 and +4 are not going to work. So we could plug in all those numbers and see which one gives us 0. Or does this look vaguely familiar? X to the fourth minus 64. So you have 2 options. Plug in all those numbers and see which ones work. See, and once you find one, you can do synthetic division, reduce it to a smaller degree, and then you can find the rest. But I happen to notice that this is the difference of 2 squares, right? Is x to the fourth a perfect square? Yes, it is. X squared and x squared, 1 plus 1 minus. See how important it is to know these common factoring techniques. 64 is +8 and -8. Okay, so we were able to break the degree 4 polynomial into smaller pieces. So now we could just set these equal to 0. X squared plus 8 is equal to 0. x squared minus 8 is equal to 0. Let's add 8. X squared is equal to 8. Take the square root. When you take the square root of x squared, you're going to get plus or minus. Now we need to see if 8 can be simplified. So we have biggest perfect square and leftovers plus or minus 2 rad 2. Okay, so how many zeros is that? Can you see that it's 2? So we have 2 rad 2 and negative 2 rad 2. I've found 2 of them. So let's go to the other one. So let's subtract 8 from both sides. Now we need to take the square root. So we have the square root plus or minus the square root of negative 8. So let's pull the negative out. That's I. And square root of 8 is 4 and 2. Biggest perfect square and leftovers. Plus or minus I. Square root of 4 is 2. Okay, so we now have our 4 zeros. So we have, now I'm going to move the 2 in the front. 2I rad 2, negative 2I rad 2, 2 rad 2, and negative 2 rad 2. Degree 4 polynomial. There is my 4 zeros.